Our project is about RF optimization of GSM coverage area using AGILENT tool. Under the guidance of Mr. H.K. Singh, the project is done by D. Bharat Kumar, V. Swaminathan, Gokul Madhav, of final year Veltech ITech. We done our project at BSNL Minambak under the guidance of Mr. K. Ramesh. The ultimate aim of our project is to maintain the quality and capacity of the GSM network and to minimize the call drops and to perform successful handover process. The main objective of our project is viewing OMC control daily, analyzing the report and post-processing of data, conducting hotspot and drive test measurements. Here comes to the abstract of our project. RF optimization is a very critical tool. We are using hotspot and drive test. With that goal, we are collecting some data. Later, we post processing of those data using an AGILENT drive test tool. Later, we measure short call and long call process. Here, the hotspot and drive test measurement is done with using AGILENT drive test tool 15.2 version. Later, we are analyzing those data. An optimization of BTS is really a big challenge. If the optimization is done successfully, the QoS, reliability and successful call drop, those things can be performed well. Our contribution is conducting hotspot and drive test, taking reference values, compare the reference values, making report and verifying those report with the benchmark values. Whereas comes to from introduction of my project, generally a telephone network consists of three types. One is PSTN, PLMN and data network. We are working under PLMN. GSM means a global system for mobile communication. The longest distance, practical distance is 35 kilometers. GSM has two bands. One band work at 900 MHz, another band at 18,000 MHz. Where the uplink and downlink bandwidth is mentioned here. GSM network architecture. It consists of mobile station, BTS, base station system, BSC. Many BTS are controlled by BSC. TRAU is a transcoder between BTS and MSC. Lot of MSC controlled by MSC. AUC means authentication. With authenticate the customer, visitor, VLR, visitor, locator, EIR means HLR, home customers details is there. In VLR, visitor customer details is there. These are the control channels. Various control channel we are using in the time pass TDMA. There comes to our project RF optimization. To maintain the quality and capacity of the network is the ultimate aim of RF optimization. RF optimization is needed for the following reasons. First is inaccuracy in radio planning, implementation, and the environmental abstraction. That what can I say is trees, buildings. These are the environmental factors which affects our quality and capacity of a network. Why GSM? GSM is a wireless network. Is always unreliable. What are the technical issues we are facing? The technical issues is like call drop, handover failures, frequency carriers may not be sufficient. What are the RF optimization is being carried out for following reasons. One is coverage, interference, handover behavior, traffic distribution. When we need to do optimization, first the RF engineer should do the planning, then implementation. After implementation, we have to do the optimization. There are two types of arrangements they are using. One is hub arrangement, one is laptop arrangement. Hub arrangement is very costly and ineffective way. So we are using laptop arrangement. We are using two types of testing. One is hot pass measurement and another drive test measurements. What are the components required? The components required is AGILENT drive test tool, GPS Dagma tool, laptop, OMC or inbuilt dongle key, test model, test mobile phones, antennas. Laptop arrangements. This is the arrangement what we did our project. These are the features of AGILENT. Less cost, easy, flexible, good, improve the network performance. This is the parameters they are measuring: RX level, RX quality, SQI, CSSR, DCR, HOSSR. These are the configuration steps. First thing is we have to install the software. Next we have to add hardware. Then you have to, after adding, you have to do a logical connectivity. Later adding of maps, adding of cell site, call process, add of data items, and finally analyzing. These are the configuration steps. First step is we have to add hardware parts like test mobiles, inbuilt dongle key, AGILENT software installation, and GPS. Next step is after hardware part is added, then you have to connect the logically. Logical in the sense we have to add those things inside the software. So we are doing a project inside the Tamil Nadu area, so we have to add a Tamil Nadu map here, which I already saved in the C drive. Next thing is adding up cell site. Adding up cell site in the sense, so we have to add a cell site and we have to look at where our test antenna is present. Call control process. The call control process, we have to make use of the call. We have to do long call and short calls. Later we have to analyze the parameters. Recording means we have to start long call and short call processes. First measurement is RX measurement. Analyze the various parameters such as cell ID, RX level, RX quality, transmit power, receive power with the fixed geographical area is called hotspot measurements. And drive test. Drive test means analyzing cell ID, RX level, RX quality, transmit power, receive power for a moving geographical area for various test antennas. These are the benchmark values. We are comparing values. First, initial hotspot long call. We have see here the receiver quality is very low initially, whereas in the short call drop is there. Later we improved call drop and receiver level. Now the quality is very fine. The same thing, no call drop is here, no call block is here, number of good calls is there. We improved the receiver quality. Everything is fine with the network. A drive test. We conducted a drive test from Minambakam to Nanganellur area. First is the initial drive test. See, the receiver quality is totally damaged. Number of block calls is there, call drop is there. So these are the various parameters we are analyzing. Later, for a long call also the same problems. Call drop is there, receiver quality is very low. After improving those things, now we improve. No call drop is there, no call block is there, no receiver quality. Receiver quality is very good. And same thing, we improved the quality. So this is the comparison between the hotspot initial and hotspot final. Generally the RX level should be -32, -70. Here initially we obtained -81 and -83. Later it is improved. The call for initially call drop is number of call drop is 3, 1. Later no call drop. Call block is also like that only 2, 1. Later no call block is there. Number of good calls initially 0, final 20 good calls. The great thing. Generally transmission quality should lie between 0 to 20. Initially we found that transmission quality is very low. Later it is improved. This is for drive test. Initially the call drop is 5, 4. Number of call drop is 5 calls, 4 calls is drop. Later those things improved. So no call drop is there. Like that no call block is there. So number of good calls improved from 0 to 32. Generally, received quality should lies between minus 30 to minus 70. Initially, we found minus 86, minus 87. Later, we improved to minus 58. Received quality is also like that only. 0 to 4 is the minimum level. Initially, 7 is there. Later, we improved to 3. Handover analysis. First issue observed. What are the first issues observed is 2 IC has same frequency level, so interference happens. So what we have to do to avoid the interference? So the action steps taken is reorient of sectors, change of frequency planning. For a long call, the problem is the timer expired. Within the call connection from mobile station to base station, when it takes more than 2 seconds, call drop or the call will be eliminated and a new call process will take place. So this problem obtained during a long call. What are the action steps taken by us? Tilt the action direction. In some highways, we can find only 2 types the sectors is there. So we have to add one more sector there. Later, increase of signal level, and if possible, we can place a new tower. Application of a project: analyze the quality and capacity. Call failure is reduced. This method is using by BSNL, Airtel, Aircel, Docomo to increase the network performance. Conclusion. Now, we have to improve the frequency planning and improve the quality and capacity of the networks. These are the main things. References. Future enhancement. Now these things are done manually. So what are the future enhancement we can do? We can do the one thing. What is we can make an automatic network management system, so that one server is there. The server processes all the data given by the client system, so all these things can be done automatically in future. Thank you.